Morning and welcome, folks. We're looking at a whole series of we're diving into electronic components again today. But today we are going beyond the components and looking at how they come together to form circuits. And this is again a very simple and low down explanation of what happens. It's all of these topics, they get complicated very fast, so we don't want to go down that route too much. But let's start with this. We have a circuit here which there's a switch, there's a battery, and there's a bulb. It's very common. You'll find it in your house, you can find it in a torch, and just about anywhere. Now, when the switch is open, none of the current is able to flow through the circuit, and hence it's called an open circuit. Even if the battery is connected, nothing else will happen until you close the circuit by turning on the switch, and then the current flows from the battery to the lamp and then closes the loop. So essentially a circuit is a sequence of these different kinds of elements connected together, and in this case they are all connected linearly in one circular fashion, and technically this is what would be called as a series circuit, because these items are connected one after the other with a single wire that goes from one to the other, right? So a series circuit would be something like this. You have a battery, and then from the positive you have one wire going to the first lamp, then the output of that lamp connects to the input of the second lamp, and the output of the second goes to the input of the third, and then the end point of the third lamp returns back to the negative terminal on the battery. So they are all connected one after the other in a sequence, and hence a series circuit. Now, what happens in a series circuit if you remove one of these bulbs, or if one of them fuses or turns off or burns away? What's going to happen is that's going to stop the current from flowing through the whole circuit, because that blown or fused or removed lamp acts literally like a switch that has been turned off. And once that happens, none of the other lamps will work, even if they are functional, even if your battery is operated, and even if you don't have any switch in the circuit, as you can see. But if one lamp fails or is removed, the whole circuit stops functioning. So that's how a series circuit can be considered, and that's not a flaw. It's basically a way to tell you how a series circuit works. Now, here's a parallel circuit where the positive connection from the battery goes to one terminal of the lamp, and then it also goes to the equivalent similar terminal of the second lamp, and then on to the third lamp. And then the black or the negative wire goes to the similar three second terminals of your lamps. Now, the advantage here is that when you turn it on, all the three lamps will glow, but if you remove one of them, the other two will continue to keep burning. Now, there's a couple of things to notice over here. In the series combination, you'll notice that we have a battery. Let's say that this is a 9-volt battery, for example, and that is connected between that voltage is shared between three devices. So technically what's happening is the voltage gets divided, because it has to pass through each of these resistive elements, which are the three bulbs. So if you have a 9-volt battery and you have three bulbs like so, each bulb will have a voltage drop of 3 volts. So 3 volts are dropped here, then the other 3 volts are dropped with the second lamp, and the final 3 volts are dropped across the third lamp. So with respect to ground, if you measure voltage in this circuit using a multimeter, and if you put the black terminal of your multimeter to this black wire here, and you connect the red to this terminal here, you will measure 3 volts across this lamp. And then keeping the black terminal here, if you moved to this terminal here, you will measure 6 volts. And then if you move that red terminal here, you will measure 9 volts. So that's known as a voltage drop across each element in a series circuit. On the other hand, if you have a parallel circuit like this, let's say this is 9 volts, then you have the same 9 volts being applied to all the 3 lamps. So, it's the same voltage that goes to all of these elements, right. If you know Ohm's law, then you will realize that how you can figure out what is happening in these two circuits, the series circuit and the parallel circuit. So, if you consider these three as resistances, it is obvious that you have R1 and R2 and an R3, and this 9 volt battery is passing current through those 3 resistors, and based on that you can measure the current or estimate the current that is going through this circuit. Now, and that is going to be a constant fixed current. Now, with a parallel circuit, things become different. Let us say this is a voltage, let us say this is a lamp rated for 10 watts, then it is going to draw a certain X amount of current that goes through it. On the other hand, if the second the second bulb is disconnected, let us take the third bulb. If the third bulb is 100 watts, then it is obviously going to draw 10 times more current than the other bulb that is rated for 10 watts. So, this is how you have the relationship between voltage, current and resistance within series circuits like this and parallel circuits like this. Now, the most commonly seen place where you will have parallel circuits is in your house. Your house receives 230 volts from your electrical supply company, right, and everything in the house works at 230 volts. So, basically all of your devices, all of your rooms, everything is receiving the same voltage, and all of the different appliances are sort of connected in parallel. So, you have a washing machine and it will have its own switch, so you can control it on and off, and then you will have a food processor, and then you will have a dishwasher, and you will have different appliances in your house like a TV and your audio, and they are all receiving the exact same voltage, which is 230 volts, but they have different limbs or circuits or sub-circuits which you can control via switches, and then they draw the current and operate. So, that is a practical kind of an explanation or reference to what a parallel circuit is. Another easy way to kind of show this is, let us say you look at your TV remote or your cordless mouse, for example. If it has just one battery, well, there is no series or parallel, but if it has 2 batteries and each of those batteries is 1.5 volts, then it is obvious that those 2 voltages add up because they are in series. So, the total voltage will now be 3 volts, but the current capacity is whatever is the capacity of any one of these batteries, right. Ideally, they would both be similar. So, if you say that these batteries are able to supply 100 milliamps of current, then that is the maximum current that you will be able to draw through this series combination at a voltage of 3 volts. On the other hand, if you take the same 2 batteries and connect them in parallel, where the negatives are joined together and the positives are joined together, you now will have a voltage of just 1.5 volts, which is half of series, but your current capacity will be now double, because you can have each of these batteries supply the same 100 milliamps of current. So, you get a total output of 200 milliamps current. So, what is happening here is in series the voltage doubles, but the current remains the same. In parallel, the voltage remains the same, but the current doubles. So, that is another way of keeping in mind how series and parallel work. And here is a little bit of a more complex example of where we have not just normal, let us say we have a normal 12 volt battery, so it is going to give you 12 volts. If you have 2 6 volt batteries and you put them in series, you are going to get the same 12 volts, right. And if each of these 6 volt batteries has the same current capacity as a 12 volt, then the current capacity of this combination will be also the same. And then you can add another 2 6 volt batteries in parallel to the other 2 that you had. So, now you have a combination of a series and parallel circuit, and this allows you to sort of increase the current capacity by adding more elements in parallel and increase the voltage capacity by adding more batteries in series. So you can play around with that and do both. If you take a normal 12 volt battery and double it up in two in parallel, you still get 12 volts, but now we have twice the current that this single battery can provide. And then you can get the same 12 volts by combining a whole bunch of 2 volt batteries in series, for example. And then you can add more of them in parallel and increase the current. So in this case, if the current is I, if you add another parallel arm, you get twice the current, for example. So that's another look at voltage, current, and how it affects a series and a parallel connection. Remember, the basis for all of these things is usually and always Ohm's law. Ohm's law really allows you to calculate a lot of very simple things in electronics and can be used in many different ways in which you want to calculate voltage, current, resistance, and power. And then we can also expand it to stuff like power factor and so on. Here's a little bit more of the same series and parallel combination, where if you have 4 different resistors connected in series, then their value adds up to whatever is the sum of all of these 4, which is, if they are all 100, then you have a total of 400 ohms. Whereas in parallel, the formula is a little bit different. It's the reciprocal value of the total resistance is the sum of the reciprocals of each individual resistor. Now, since these are all equal 100 ohms, then what you get is 1 upon 100 plus 1 upon 100 4 times, and then if you solve this whole problem, you can find out that the sum or the total resistance of 4 resistors in parallel is 25 ohms. And it's pretty easy to do this visually if the values are the same. If you have 2 in parallel, then the value is half, so it will become 50 ohms. If you have 3 in parallel, the value will be 1/3, so it will become 33.33 ohms. And if you have 4 in parallel, you get 25 ohms. If you have 5 in parallel, it becomes 20 ohms, and so on. But if the values are different, you have to plug them into this formula and then calculate it the good old-fashioned way using a calculator. And then you can also have combinations of series and parallel resistor connections and so on. So it's useful to know these kind of relationships, because it helps you when you are trying to answer the question, what resistor do I need to connect to an LED so that it doesn't burn up if I connect it to 9 volts, and I know that the LED requires 2 volts at 10 milliamps. So this kind of a question can be answered using something similar to this. It's basically just the application of Ohm's law. And this is the example that I was talking to you about. If you have a 9 volt battery and you have an LED, then what resistor do I need to use so that the current through the LED is not excessive and it doesn't burn up, and how do I calculate that? So I figured out that this is 9 volts, the drop across the LED is 2 volts, so I need to drop 7 volts across the resistor. And then if I know the current that it needs to flow through the LED, then because I know the voltage drop and the current, I can find the resistance, which will be V upon I, which will give me the value of this, resistor. Now, obviously, while drawing circuits, it will be quite painful if we have to draw each element as it looks physically. Drawing all of these details will slow everything down, is not really visually appealing, and could get very complex and so on. So this is not really an ideal way of drawing a circuit. The correct way is to replace each of these elements with their schematic symbols, and that gives us a circuit diagram or a schematic. So here we have shown the voltage source with plus and minus. We have a resistor and we have a diode, and we connect it all together. Then we can do all of these calculations. The voltage of the source is 9 volts. The LED is voltage is 3.3 volts at 30 milliamps. So then R needs to be V upon I, which is 9 minus 3.3 divided by 30 mA gives you 190 ohms. And since it's difficult to get each and every value of resistor, we would round this off to maybe 180 ohms or 200 ohms, which are the two values that you can commonly find around this number. And what should be the value of this resistor in terms of its wattage? We need to know the power dissipated is voltage times current, which is about 0.171 watts. So I know that if I use a 1/8 watt resistor, which is 0.125 watts, it won't be enough because the current is pretty high, and I need to use at least a 1/4 watt resistor, 0.25 watts, or maybe even higher, to make sure that this resistor itself doesn't burn up because of excessive heat dissipation. So these are the kind of thoughts processes that goes off in a very simple circuit, which is just 3 elements. So you can imagine how things get complex with more complicated circuits, and it's really helpful to know that at the bottom of it all, in most cases, it's almost always just simple pure Ohm's law. So that's kind of a little bit of a rundown on what is series, what's parallel, how voltage, current, and resistance and power interact with each other, and how you can kind of visualize that in a very simple circuit that has just a couple of elements. So this is just the start of a long journey of examining and trying to learn and design your own circuits. Keep designing, and I'll see you again later.